Hi, I'm Sheen. Well, we've considered a bit of the theory behind ANOVA. Now let's take a look at how we actually do the analysis.
There are actually several flavors of the ANOVA test. One way ANOVA compares the mean values of multiple datasets. It seeks to determine if there is a significant difference. Two-way ANOVA compares the means of independent factors within the datasets to determine if there is a significant difference. We can do the one-way ANOVA analysis in three different ways. We can do it manually using the table on the next slide. We can use Excel, or we can use a statistical software package such as Minitab. For two-way ANOVA, you have to use a statistical software. Like many of our hypothesis tests, the results of the ANOVA can be shown graphically or with a statistical value. Let's look at the manual method with the F distribution table. You may have a question on the Isaac Lean Six Sigma Black Belt exam that will require the use of this table. The table is based upon several dataset parameters. In this case, we're using an alpha of 0.05. If different parameters are used, it will require a different table. We will do a quick exercise. We have 3 samples, and each of these 3 samples is made up of 6 items. The column entry is the degree of freedoms based upon the number of samples. Well, that degree of freedom is calculated by subtracting 1 from the total number of data sets. In our case, that means 3 minus 1, which is 2, so we go to column number 2. Now the row entry is the sum of the degrees of freedom for each of the unique samples. Since each sample in this case had 6 items, the degree of freedom for each sample is 1 less than that, or 5. And since there are 3 of those, we add 3 5 times and come up with a total of 15. So we go in on row 15. So looking at column 2 and row 15, the F value then is 3.68. Now let's look at how we do the test in Excel or Minitab. In Excel, select the Data Analysis menu from the Data ribbon. Then select ANOVA Single Factor. Note whether the data is grouped by rows or columns and provide the range for the data table. The rows or columns must be next to each other. There cannot be any blank rows or columns in the data. Excel will calculate a p-value. In this example, the p-value of 0.022 is less than 0.05, so reject the null hypothesis. The mean values are statistically different. Minitab will go one step further in its analysis using ANOVA. Start in a similar manner, so go to the Stat pull-down menu, select ANOVA, then select One Way. Select the format of your data columns like you did on other tests, then select the data columns for analysis. Now go to the Options panel and select Equal Variance if you have that condition. Also, you can go to the Graphs panel to select the types of graphs that you want. I recommend the interval plot under the data plots and the 3-in-1 residual plot. Minitab will provide both plots and a summary of the analysis in the session window. As you can see, one of the items it provided is at the p-value, which is 0.022. Let's take a minute to look at the graphs that we get from Minitab. The Minitab and Excel p-values will tell you that there is a statistically significant difference in the means, but that doesn't tell you which sample was the problem. This is where the graphs add value. A quick glance at the graphs will normally reveal the difference. As I mentioned on the last slide, select the Graphs button and then select both data graphs and residual graphs. Personally, I like the interval plot, but if a different view works better for you, then use it. You can select individual residual plots or do the 3-in-1 or 4-in-1 option. So let's look at the interval plot. We have 4 different categories of data, and the mean was definitely changing between these different categories. The mean for time 1 falls within the confidence interval for time 2, and the mean for time 2 falls within the confidence interval for time 3. The mean for time 3 falls within the confidence interval for times 2 and times 4, and the mean for time 4 falls within the confidence interval for time 3, but the mean for time 4 does not fall within the confidence interval for time 1. There's no overlap of those confidence intervals, so they're clearly not from the same population. We may need to look at other contextual information to understand the possible reason for the difference. That could include looking at the residual plots. This line does not look normal, and we would expect that since there are different populations in the data. That is a typical reason for non-normality, and we see that the histogram is heavily skewed, again an indication that the data is not normal. It's interesting to note that the versus fit data shows that the range of residuals was similar except for that outlier point on the sample at the far right. The point is in the upper right corner of that plot. But since the residual versus fit is similar on the other plots, this is probably not a time-based pattern at work, but rather there's some other special cause attribute not reflected in this data that's affecting these samples. So far, we've been trying to evaluate one factor with multiple samples. However, we can also have multiple factors when working with ANOVA. Both Excel and Minitab can run an ANOVA with 2 response factors, and Minitab can even run it with more than 2. In Excel, select the Data Analysis menu on the data ribbon, and then select ANOVA 2-factor without replication. We'll talk about replication when we do the class on design of experiments. Now enter the data range in the same way as you would with a one-way ANOVA. The Excel results will provide a p-value for both a column analysis and a row analysis. In Minitab, start with the Stat pull-down menu, select ANOVA, select General Linear Model, then select Fit General Linear Model, and you get this panel. Next, select your response columns, and then select your factor columns. You can even include interaction effects by selecting the Model button, and then on the panel that comes up, deciding which categories of interaction you want to include, and selecting the Add button for that category.
Well, there are several ways to do the ANOVA analysis. Take your pick based upon the tools available to you.